Hello everyone, welcome back. Today we are going to spend another day on Webster's method, and this time comparing it to the other methods as well, so we can see them all side by side and just make sure that we're making mental notes of the differences between the three methods that we have learned so far: Hamilton, Jefferson, and Webster's. All right, so in this particular example, we have a House of Representatives in a state that has 40 seats. The seats are apportioned to 5 counties in the state based on their population. We want to apportion 40 seats based on the populations given below. So we have our populations here for the different counties. So the first thing that I'm going to do here is I'm just going to take these populations and I'm going to add them up. Okay, and when you do that, you should get 1,524,000 for a total population, and I'm going to go ahead and take that and divide it by 40 to get my divisor. If done correctly, you should get 38,100. This is an important number. It's a number that you will use in all three of the methods, so it's the first thing that you should find when you're doing any of the apportionment methods. We need that divisor. Okay, so we're going to apportion using all three, and I have these tables set up for us down here. So we'll start with Hamilton's method, and I'll show you how I use these tables to help me keep things organized. I don't know how you guys are organizing this, like if you're doing it in a notebook or if you're printing out my notes or whatever, you can use these tables to help you out. Tables are always a good thing. Okay, so we found our divisor already at 38,100. Now we're going to go through and get our quotas. We've seen this many times before, but we're going to take the population for each individual county and we're going to divide by the divisor that we just found. All right, so there's the results of all of those divisions. Now what Hamilton said to do is just to chop off the decimal portions, ignore them, act like they're not there, and just take the whole number of parts to get our initial apportionment. So we've got 5, 7, 10, 5, 7, 8, 10, and 6. And then you want to add those up and see if we have apportioned enough, right? So if I add these together, we get 36, so that's not even close. We needed to apportion 40, so we have 4 bonus representatives that we need to give away here. So we look at the decimal portions now to get our final apportionment. Whoever has the highest decimal portion after the whole number gets the bonus representative. So we got to find the 4 highest because we had 4 bonus representatives. So we'll start with Grant County here, who had a 0.9, so that 7 will get bumped up to an 8. All right, the next one here is David County, who had a 0.8924 decimal portion. That's the second highest, so that 10 gets bumped up to an 11. The next highest is the 0.766 here in Colton County. No, it's not. Sorry, the next highest is Adams County, which is 0.7743. So that one will get bumped up to 6. And then we'll go back to Colton County because they had the next highest at 0.7664. So they will bump up to 9. And then that's all of the bonus representatives. So Hayes County will not get a bonus, so they will just stay at 6. Now when I add those up, I have 40 representatives. All right, that is Hamilton's method. You might want to remember that one. They have the bonus representatives, so there's no modifying of the divisor. Whatever keywords you need to throw in your head to remember which one is Hamilton's, I would do that. Okay. All right, let's look at Jefferson's method. Now, Jefferson's method is almost the same up until we get to that initial. So we got the same divisor. Okay, so we got 38,100. All of the quotas will be the same as what we calculated in Hamilton's method. Okay, so we got the same quotas there. Now, to get our initial, we do the same thing that we did in Hamilton. We ignore the decimal parts and we just take the whole number parts. So we're going to have 5, 7, 8, 10, and 6. And when we add those together, we get 36. So we know that's not enough. So we do need to go back and modify the divisor. This is where Jefferson differs from Hamilton. We're not going to be awarding bonus representatives. Instead, we go back, we have to modify the divisor and recalculate a new set of quotas, and we'll get a new initial allocation. Okay, so I'm going to lower our modified divisor. I'm going to lower the divisor to increase the number of representatives that get apportioned here. So I'm going to lower this down to 35,000. That'll be my modified divisor, and I'm going to do the work with my new divisor here in these next 2 columns. So I'm going to take each individual population for the counties. I'm going to divide by 35,000 this time and see what I get for my new quotas. All right, so there's my new quotas, and you can see the difference between the old quotas and the new ones based on my modified divisor here. But we're going to do the same thing. We're going to chop off the decimal parts and just take the whole number parts here. So we'll get 6, 8, 9, 11, and 7, and then we'll add those up. And if we do, we get 41. So that is too many. So we went too far when we lowered the divisor here. So I'm going to go with a new modified divisor. I'm going to go up to 36,500, trying to split the difference between 35 and 38 here. So I'm going to go back up a little bit to decrease the number of representatives that I apportioned. And I'll have another set of quotas and another initial, and hopefully we get it right this time. So I'm going to take 36,500 as the divisor with each individual county. Okay, so there's my new quotas, and again, you can compare those so you can see how our quotas have developed as we have changed our divisors in this particular problem here. So I'm going to go through and do the same thing. I'm ignoring the decimal portions, taking the whole numbers. So we got 6, 8, 9, 11, and 6. I'll add those up, and I get my 40 representatives. So 40 works, which means this will be the divisor that I use, and this will be my final apportionment now. Okay. All right, that is Jefferson's method. That was a really tedious example of Jefferson's method because I had to do two divisors there. So that is one of the drawbacks of any modified divisor method, is that there is a lot of trial and error sometimes. Okay, there's no way around it. It's part of the problem. It means you're doing things right. Okay. So let's take a look at Webster's method. It starts off the same, 38,100. We're going to use that same divisor and the same quotas that we had here in Jefferson's method. All right, so now we actually do something different. We're not just going to chop off the decimal portions here. What we're going to do is we're actually going to round to get our initial apportionment. So 5.77 is going to round up to 6. 7.95 rounds up to 8, 8.76 rounds up to 9, 10.89 rounds up to 11, and 6.61 rounds up to 7. And then we got to add those together and see what we get. And if you add those together correctly, you'll get 41, which is too many. And if you recall from the last notes, when you get too many, you have to raise the divisor. Right, that way you know at least which direction to go. Right, so if you get too many, you raise it up. If you get too few, you lower it down. Okay, so we're going to get a new quota and a new initial, and let's hope that we guess a good one. I'm going to go up just a little bit. I'm going to go from 38,000 to 39,000 here and hope that I get it right this time. So I'm going to go through, take my individual populations. I'm going to divide by 39,000 and get a new set of quotas. All right, so here we go. All right, so there's our new quotas, and again, you can compare those to the old ones so you can see what changes were made. Remember, we are still rounding because we are in Webster's method, so we're not just taking the whole number parts. We actually have to round first, then take the whole number part. So 5.6 rounds up to 6, 7.7 rounds up to 8, 8.5 rounds up to 9, 10.6 rounds up to 11, and 6.4 will stay at 6. So if I add those together, I do get 40, right? So that works, which means our modified divisor will be 39,000, right? This becomes my final apportionment, okay? So you can, if you want to, you can add another column and you can say final over here and just rewrite the numbers. But once you have found the divisor here, there's really no need. It's just repetitive work. That initial becomes your final as long as they add up to the number that you need. All right, guys, that is it for today. Give the practice problems a try. Make sure you're getting ready for that quiz at the end of the week. Have a great day.